Hey there, and welcome to another Calculus 1 video. This is about derivatives of trigonometric functions. We are dealing specifically with the trig function derivative rules. We're not applying anything with regards to the chain rule for those of you who are not in my class. If you are in my class, then you don't know what the chain rule is yet. So we are just looking at the derivative rules for trig functions, and we're going to look at how those apply on top of the other rules we've already learned in sections 3 and 4. So you may want to pause the video and write these 6 down. These are your trig rule derivatives. You've got 6 trigonometric functions. They each have a rule, and as you can see, there's kind of a little bit of a pattern. If you look at the derivative of sine, you get cosine. The derivative of cosine, you get negative sine. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. The derivative of secant of x is secant of x times tangent of x. The derivative of cosecant of x is negative cosecant of x cotangent of x. So all the cos get a negative in front of them when you take their derivatives, and the tangent and secant and the cotangent and cosecant match up pretty much perfectly, and sine and cosine just go with each other. Okay, so a couple of really notational things to start with. SEC is the best football conference in college football, but it is not a trig function. It must have an x, or cosine of theta, or sine of t, or something like that. But just writing sin is a sin mathematically. It means nothing. So you must have an argument. Okay. The other thing is that these two are products of two functions. There is no function called sectan. Right? This is secant of x times tangent of x. So the derivative of secant is actually a product of two things. Same thing for cosecant. The derivative of cosecant, that's a product of two things. So your notation, as always, is very important, and so make sure you have your x's involved there. Some of your pre-calc teachers may have let you get away with sin and cos and tan and that kind of stuff. No more. Right, you got to have an argument there. You got to have an angle. Okay? So we're going to use these rules and see what they look like. Example 1, I want to find f prime of x for the given function. And so what do I have here? I have the constant 2 times cosine. 2 is a constant, which means it just comes along. And the derivative of cosine is negative sine of x. Again, I need to remember that. And then minus 6 times secant. The 6 is a constant, it just comes along. The derivative of secant of x is secant x tangent x. Now, I don't really care if you have parentheses around the x's or not. When it gets to be more than just an x, then yes, we're going to need those parentheses as well. But for right now, it's okay. And then the derivative of 3 is 0. All right, and so I don't want you to leave it like this. I do want you to combine this negative 2 sine of x minus 6 secant x tangent x. And that's good enough. Okay. If you can go straight from here to here, that's fine by me. That's great. Okay? So, I want you guys to pause the video and try to find g prime of z this time. The x is not the variable, z is the variable, and that's fine. It's the same rules. So you got 10 tangent of z, I said it, right? 10 tangent of z minus 2 cotangent of z. Pause the video, take a shot. Okay? What's the derivative of tangent? Secant squared, so we end up with 10 secant squared of x minus 2. What's the derivative of cotangent? Negative cosecant of x squared, and these are not x's, they're z's. I did it again. So be careful. My math lab, remember, my math lab's picky. You got to use the right variable, so make sure you're paying attention there as I demonstrated how not to do it. So you get 10 secant squared of z plus, two negatives make a plus, 2 cosecant squared of z. All right? So those are the basic, some of the basic derivative rules for trig functions. Now, what happens if we put them in tandem with other functions? Example 2 here. I want to find f prime of w. And what do we have now? We have a product of two things, tangent w times secant of w. And so in order to do that, I have to do the product rule. Remember the product rule, you get first times derivative of the first times the second plus the first times the derivative of the second. For those of you that are used to writing this out and using like big F and big S or F and G or whatever, that's fine. Just be careful. And so if big F is tangent of W, then big F prime is the derivative of tangent, which is secant squared of W. S of W is secant of W, and so S prime, the second derivative, is the derivative of the second function, not the second derivative. The derivative of the second function is secant W tangent W. And again, you need two, this is a product of two functions, you need two W's. So plug that into this formula and end up with secant squared W times the second, which is secant of W, plus tangent of W times secant tangent. Kind of ran out of room here. All right, so the actual answer here, if we simplify it a little bit, we get secant squared times secant, that's secant cubed of W. And then here we have a secant and two tangents, and so we get secant of X tangent squared. W, not X. Okay, it's good practice to do all these different variables because the variable doesn't actually matter unless you have more than one, and you won't deal with that till Calc 3. So anyway, so that's F prime of W, secant cubed of W plus secant W tangent squared W. Okay, so pause the video. I want you guys to try to find H prime of T. Notice that it's separated, two terms here separated by subtraction, but then this term has a multiplication symbol. So see what you can do. Okay, so H prime, what do we have here? Well, the first one is just the derivative of t cubed, so that's 3t squared. Then we're going to subtract the group product rule. So this is a product. The product rule gives you a group of things, and so therefore I need to group it that way. Now if you aren't using if you're using the big F and the big S, you'd need to write that out, but my first function is t squared. The derivative of that is 2t times the second function is sine of t, and then plus the first function t squared times the derivative of sine of t, which is cosine of t. Okay, and then if you wanted to simplify this a little bit, you distribute that negative sign through, you get 3t squared minus 2t sine of t minus t squared cosine of t. And that's the answer. Okay? So again, we're just building on the rules we already had. If you aren't real comfortable with the products and the quotient rules, then you're going to want to go back and make sure that you know those well before you jump into this. Okay? I'm going to do one more example where we combine multiple rules. Here we have a fraction. It's x to the fifth times e to the x, and then the denominator is cosine of x plus 1. And so if we're going to find y prime, what's the big picture here? The big picture is I have a numerator and a denominator. So I have a top function, which is x to the fifth e to the x, and I have a bottom function, which is cosine of x plus 1. And so when I go to do the derivative rule for quotients, I get the bottom times the derivative of the top. Well, what is the derivative of the top? The top is a product. So I have to do the product rule, derivative of the first, 5x to the fourth, times the second, e to the x, plus the first x to the fifth, times the derivative of e to the x, which is e to the x. All right? And then minus the top, x to the fifth, e to the x, times the derivative of the bottom. The derivative of cosine is negative sine. The derivative of 1 is 0. So I get a negative sine of x there. And then the entire thing is over the entire bottom, cosine of x plus 1, all squared. This does not simplify, okay? But you can distribute the negative up top. I'm not going to multiply out the top. Just leave it as a group, cosine of x plus 1 times 5x to the 4th e to the x plus x to the 5th e to the x plus x to the 5th e to the x sine of x. And then that's all over cosine of x plus 1 all squared. Okay? So once again, as I've mentioned before, these sections that we're working on right now require lots and lots and lots of practice. I can't possibly give you enough examples to show you all the little different nuances, and so you need to work through the worksheets, the My Math Lab examples and problems, pull out your textbook and take a look at it, and if you guys need more problems than I've already posted, I'm always happy to give you more. Okay? So hopefully that helps, and we will see you later. Thanks.